Hello students, last class we discussed some analytical questions based on aliphatic amines. Now today we are going to discuss some questions linked with aromatic amines. Okay. So similarly first read 2 to 3 times, then find out the clue, and from this clue try to solve this type of problem. So an organic compound A on treatment with aqueous ammonia and heating forms compound B, which on heating with bromine and KOH forms a compound C of molecular formula C6H7N. Write the structure and IUPAC name of compound A, B and C. So organic compound A on treatment with ammonia, if reacts with ammonia, we may conclude that, consider that A may be one acid which treated with ammonia and forms compound B. That means it may be an amide. And amide when treated with bromine and KOH, actually this one is the clue. When an amide treated with bromine and potassium hydroxide forms a compound C of molecular formula C6H7N. So from this formula C6H7N, we can know this one also one clue, this one is one clue. So from this formula we can know the compound is C is one amine, and that is any compound, nitrogen compound treated with bromine and potassium hydroxide forms again one nitrogen containing compound. That means it may be amine, and it is derived from by heating a compound with bromine and potassium hydroxide. That means that compound is an amide. So it may be an amine. So what is the formula? From this formula, how can we identify the compound? The compound may be aniline. So we can write C is aniline, as the formula is C6H7N, and which is formed by heating bromine and KOH, potassium hydroxide. That means it may be an amine, and that amine is your this one. That is 1, 2, 3, 4, 5, 6, and there are 5 and 2, 6, 7 hydrogen atom, 6 carbon atom and 1 nitrogen atom. That is your aniline. And this aniline is formed by Hofmann-Bromamide degradation. Then what is that amide? That amide is benzamide. So bromine and potassium hydroxide on heating. So in this way that amide is benzamide, and which is formed by treatment of A with aqueous ammonia. Then this is formed from what? When one compound heated with ammonia. So that compound, either liquid ammonia or aqueous ammonia. Okay, so it is your acid. It may be acid. So A is this one, B is this one, and C is this one. What is the name of this compound? Benzoic acid, or we can say benzene carboxylic acid. IUPAC name, but this name is also, the common name is also considered as your IUPAC name. Then what is this compound? This is benzamide. And what is this? This one is aniline or benzenamine. This is aniline or benzenamine. This is benzamide, and that one is benzoic acid. So you have to write as the formula is this. This may be an amine, it is derived from bromine and potassium hydroxide. The compound B may be an amide, and amide the compound B is formed from a compound on treatment with ammonia and heating. That means A may be carboxylic acid. So in this way, C is this one, B is this one, and A is this one, and you have to write the overall reaction. Okay, next come to question number 2. Okay, a colorless substance A, again formula C6H7N, is sparingly soluble in water and undergoes water and gives water soluble compound V on treatment with mineral acid. So as it reacts with mineral acid and it forms a water soluble compound, that means it must be a basic compound, and the basic compound or the base formed by this formula, this is aniline. From this formula we may conclude that the formula is maybe for amine, that is for amine, and that amine is aromatic amine, and that one is aniline. Aromatic amine, and that one is aniline. And aniline, when treated with mineral acid, suppose we treated it with mineral acid like hydrochloric acid, or when treated with sulfuric acid, it forms a salt, that is water soluble salt, NH3 plus Cl minus. This is anilinium chloride. And aniline, and this is water soluble. As it is a salt, it is water soluble. On reaction with chloroform and alcoholic potash, A produces an offensive smell. As A is a primary amine, when it reacts with chloroform and alcoholic potash, it forms carbylamine. It forms a carbylamine which has offensive smell. Then what is that? So this is aniline, and when treated with chloroform and potassium hydroxide, it forms phenyl isocyanide plus water. Okay, well, this is, so it has offensive smell. Treatment with, on reaction with alcoholic potash, A produces offensive smell due to formation of compound C. So this is your compound C. Reaction of A with benzene sulfonyl chloride gives a compound D which is soluble in alkali. Again we know primary amines reacts with benzene sulfonyl chloride, which when treated with an alkali, this form a salt and these are soluble. So what is that product? So aniline plus benzene sulfonyl chloride. So it forms NHS here minus hydrochloric acid it forms N-phenyl benzene sulfonamide. N-phenyl benzene sulfonamide, When treated with potassium hydroxide, it forms a salt N minus and K plus. So it gives a compound D. So this one is D. With NaNO2 and HCl, A forms a compound E, which reacts with phenol in alkaline medium to give an orange dye F. Then this aniline NH2 reacts with NaNO2 and HCl, that is nitrous acid at 0 to 5 degrees Celsius. It forms benzene diazonium chloride N2 plus Cl minus and forms E, which reacts with, so this is E, and which reacts with phenol, E, which reacts with phenol in alkaline medium to give an orange dye F. Then what is that compound? So this is benzene diazonium chloride. When it reacts with phenol in slightly basic medium, pH 9 to 10 and temperature 7 to 73 Kelvin, that is near ice cold temperature, it forms para-hydroxy azobenzene. Okay, so A is aniline, B is anilinium chloride. If you take sulfuric acid, then anilinium hydrogen sulfate, and this reacts with chloroform. A reacts with chloroform and potassium hydroxide to form phenyl isocyanide. This one is C. Then aniline reacts with benzene sulfonyl chloride followed by potassium hydroxide to form the salt of N-alkyl benzene sulfonamide, potassium salt of N-phenyl benzene sulfonamide. This one is D, potassium salt of N-phenyl benzene sulfonamide, and again aniline treated with nitrous acid to form benzene diazonium chloride. This one is E, and this benzene diazonium chloride E again reacts with phenol to form para-hydroxy azobenzene, and this one is F. So A is aniline, B is anilinium chloride, C is phenyl isocyanide, D is potassium salt of N-phenyl benzene sulfonamide, E is benzene diazonium chloride, and F is para-hydroxy azobenzene. Now, next comes some other questions. An aromatic compound A of molecular formula C7H7ON. That means benzene ring, it contains another one carbon. Undergoes a series of reactions as shown below. Write the structure of A, B, C, D, E in the followings. Look here, C7H7ON. So this one is A. When reacts with bromine and KOH, it forms C6H5 NH2. This is aniline. As it is aniline, then what is A? This must be an amide, and this amide, when treated with bromine and potassium hydroxide, it undergoes Hofmann-Bromamide reaction. Hence, it forms aniline. So, what is then A? So, A is benzamide, having formula C7H7ON. So, A is benzamide. And benzamide, when treated with this, it forms aniline. Then aniline, when treated with chloroform and potassium hydroxide, carbylamine reaction, NH2 group is converted to phenyl isocyanide or phenyl carbylamine, C6H5 NC plus, this is the side product, and this one is phenyl isocyanide. This forms phenyl isocyanide. And when this compound, so this one is D. And when this compound treated with sodium nitrite hydrochloric acid at low temperature, it forms benzene diazonium chloride. Hence, B is benzene diazonium chloride. This one is B. And B, when heated with potassium iodide and heat, what it forms? It forms iodobenzene. Hence, E is iodobenzene. This one iodobenzene. This one is E. And C. So when B is benzene diazonium chloride, when treated with ethanol, it undergo reduction and this compound undergo oxidation. So it undergo reduction to form benzene. So what is C then? C is then benzene, and B is benzene diazonium chloride. So A is benzamide and this compound is aniline. B is benzene diazonium chloride. B, benzene diazonium chloride. C is phenyl isocyanide, phenyl carbylamine, and E is iodobenzene, and C is benzene. Okay. Next come to question number 4. So a compound A, C7H5N, that means the aromatic compound contains 6 carbon and another group is attached which contain carbon and nitrogen, and there is no hydrogen. The phenyl group along with some compound contain carbon, nitrogen, there is no hydrogen. From this formula you can know. A compound A on hydrolysis with strong aqueous acid, gives another compound B, which is monobasic aromatic carboxylic acid. So this compound hydrolysis gives aromatic carboxylic acid. So from this formula we can know this compound is first, this is one first phenyl group, C7H5, it contains 6 carbon. Another compound contains carbon, here 5 hydrogen. In this way, the compound is cyanide. This group is cyanide. This is phenyl cyanide. It may be phenyl isocyanide, but it may be this or it may be phenyl isocyanide. But aqueous acid gives another compound B, which is monobasic aromatic carboxylic acid. If this compound undergo hydrolysis, it may form formic acid. This is an aliphatic acid and an aniline, but it forms monobasic aromatic carboxylic acid. As it forms monobasic aromatic carboxylic acid, so the compound A is this one. So that this on hydrolysis, this compound on hydrolysis forms benzoic acid, which is monobasic and aromatic carboxylic acid. So from this formula we know this compound may be this or this, as it gives aliphatic acid and aniline. But our question given monobasic aromatic carboxylic acid, that means the compound is phenyl cyanide. So A is this one. Next, the compound B. Okay, so this compound on hydrolysis, in acidic hydrolysis, it forms with liberation of ammonia. The compound B on treatment with ammonia gives a salt. So when this treated with ammonia, when this compound treated with ammonia, so when this compound treated with ammonia gives a salt. So it gives a salt. This is acid and reacts with ammonia to form a salt. This is a base to form ammonium benzoate. This is ammonium benzoate, which on heating gives C. If you heat it, then removal of water molecule and it forms benzamide. It forms benzamide. The compound C undergoes Hofmann-bromamide reaction. Then benzamide undergo Hofmann-bromamide reaction, Br2 and KOH. This is Hofmann degradation reaction. Amide reacts with bromine and potassium hydroxide to form an amine. This is aniline. Reaction to yield aniline. So this is aniline. As this is aniline, this must be benzamide. As this is benzamide, this one is carboxylic ammonium salt, ammonium benzoate. And as this is ammonium benzoate, this must be benzoic acid. As this is benzoic acid, this must be phenyl cyanide. So this is A. This is salt B. This is the compound B on treatment with ammonia gives a salt. So B on heating gives C. C is benzamide and this is the salt, and C undergoes Hofmann-bromamide reaction to form aniline. So A is phenyl cyanide, B is benzoic acid, C is benzamide. Okay, and this compound is aniline and that one is the salt of benzoic acid. Next come to another question. A mixture of two aromatic compounds A and B was separated by dissolving in chloroform, followed by extraction with aqueous potassium hydroxide solution. The organic layer containing compound A when treated with alcoholic solution of potassium hydroxide produces a compound C associated with an unpleasant odor. The alkaline aqueous layer, on the other hand, when treated with chloroform and then acidified, gives a mixture of two isomeric compounds D and E of molecular formula C7H6O2. Identify the compound A, B, C, D, E and write the structure. So look here. Here there are two types of solvent. One is aqueous solvent, another is non-aqueous solvent. So aqueous solvent is potassium hydroxide solution and non-aqueous solvent is chloroform. And whatever you studied about these organic compounds, you know all total there are two reactions which contain both alkali and chloroform. That is one is your Reimer-Tiemann reaction, another your carbylamine reaction. So carbylamine reaction given by aniline, carbylamine reaction given by primary amines, and as this is aromatic, this is aniline, and another reaction which is where the solvent is potassium hydroxide and chloroform, that is your Reimer-Tiemann reaction, which is given by phenol. And another thing, phenol is, so this is the clue. We have to consider what are the arguments. So overall we know two reactions where two types of solvents, chloroform and potassium hydroxide is there. So one is Reimer-Tiemann, another is carbylamine. So carbylamine reaction given by amines and Reimer-Tiemann reaction given by phenol. So that first keep that in mind. Next, so as amine is a base, it is insoluble also with a base in this way, and it is soluble in organic solvent in this way. So two A and B was separated by dissolving in chloroform. So the organic layer, that is A, the organic layer, that must be aniline. The organic layer, that must be aniline, because that is a base that is insoluble in aqueous potassium hydroxide. In this way, the compound A is aniline. So the compound A is aniline. And this aniline, when treated with chloroform, and so the solvent is chloroform, and treated with alcoholic potash, the compound A when treated with again alcoholic solution of potassium hydroxide, alcoholic potash. So first this is insoluble in aqueous potash, but this contains solvent chloroform and treated with alcoholic potash. So it forms phenyl isocyanide. This is NC. Have the formula C7H5N. So this is C7H5N. So this is A and this one is C. Next, so this is your organic layer. This is organic layer and this is the reaction. Okay. Next, the aqueous layer, the alkaline aqueous layer. So at the alkaline aqueous layer, that means another compound which reacts with aqueous potassium hydroxide in chloroform, that one is phenol. So the alkaline aqueous layer, that contains your phenol, that contains, when treated with chloroform and acidified with mixture of two isomers, isomeric compound D and E of molecular formula, this one. So identify this. So what is that? That compound, the aqueous layer compound, that is your phenol. So phenol when treated with chloroform, the solvent is chloroform is there. So in this way, when this is treated with chloroform and potassium hydroxide, that is your aqueous potassium hydroxide, it forms a mixture of orthohydroxybenzaldehyde and para-hydroxybenzaldehyde. It forms a mixture of orthohydroxybenzaldehyde and para-hydroxybenzaldehyde. So you have to write these arguments, then you have to write these equations. So we know two reactions. One is where solvent is chloroform potassium hydroxide, that are your carbylamine and dimertimine reaction. Aniline being insoluble in aqueous potassium hydroxide, it is soluble in organic solvents, chloroform. Hence, this is your aniline treated with chloroform, and when treated with potassium hydroxide, it forms phenyl isocyanide. So this one is A and this one is C. On the other hand, the aqueous layer which contains aqueous potassium hydroxide, that contains your phenol. So this compound is phenol, and some solvent it contains chloroform. When phenol treated with chloroform and potassium hydroxide, it forms orthohydroxybenzaldehyde, that is salicylaldehyde, and para-hydroxybenzaldehyde. So this is your C, this is your D, and this is E. Okay. So today, up to this, next class we will discuss some other chapter.